Hello everyone and welcome back to our trig videos. This one's a little bit different. We're going to be looking at non-right triangles in this case. And that becomes a problem for us because in our old examples we were able to label the sides opposite, adjacent, hypotenuse, but when there's no hypotenuse, so for example in this triangle here, there's no hypotenuse because it's not a right triangle, well now we can't label it that way. And then we can't use the similar triangle approach that allowed us to develop trigonometry. So in this case, what we're going to have to do is we're going to have to split up the triangle into right angle sides. And I'm just going to show you kind of how this would work if you wanted to use this method in order just to solve for missing sides and angles. So if I make this a right angle here, now you can see that if I was to know this angle and I knew this side, well, I could find the height of the triangle. And then once I know the height of the triangle, I could use the height of the triangle and this side to find that angle. And once I knew that angle, well, then I can use this angle and this side, or that side, to find this side. Likewise, I could find that side over there. I could add these together, and then I would know that side. And then once I know that side, I could actually use, well, actually I know C and B now. I could find A by subtracting from 180. So it is possible that if you only know outside measurements, to then use them to find the height, and then use the height to find other outside measurements. That's a whole lot of work. So let's erase that. We don't want to do that. So what we're going to do is we're just going to follow through that process once. And in doing so, we're going to develop a formula that doesn't require us to know anything about that height. So we don't want that. And so just starting us off here, I'm going to label this H. And so what we're going to do is we're just going to start with a reference angle, C. We're just going to think of this small triangle, which I'm going to kind of scribble in with red. Okay? So this triangle right there, we're going to call this the red triangle. Okay? And in the red triangle, what we're going to do is we're just going to think of these measurements here, B and H. We don't want to think about this down here, this X, because it's a piece of A, and that's a lot of work. So let's not even worry about that. So what we have is the opposite side and the hypotenuse of this red triangle. And so we have the sine of C is equal to the height, which is the opposite side, over B, the hypotenuse. And if that's confusing to you, just remember that you could draw this out, right? Label it X, H, and B, and then opposite and hypotenuse. And you could do that through our old kind of method where we were very careful with our labeling. I'm just kind of skipping steps here to get through this. So I'm going to multiply both sides by H now. I'm going to get H is equal to B sine C. I'm just going to leave that as the information that I know from the red triangle. Well, let's go over to the green triangle now. Let's make this one green. Okay, so there's our green triangle. So we got our green triangle. And I'm just going to look at angle B. And so now the opposite side is H, but the hypotenuse is C. So we're going to write out the same idea. Sine B is equal to the opposite H over the hypotenuse C. Now let's multiply both sides by C, and I'll get H is equal to C sine B. Well, now I have two equations for H. So if H is equal to B sine C, then it's also equal to C sine B. So B sine C then must be equal to C sine B. Okay, now I'm just going to clean this up a little bit. I'm going to divide both sides by B and divide both sides by C. And when I do that, I'll end up with sine C over C is equal to sine B over B. Now, I could have split this triangle differently, right? So let's take a look at how I could have done it. I could have chosen to do something like this instead. And I could have drawn it like that and had this whole argument with A and B. And I would have ended up with the same result. So I'm just going to tack on the other result, sine A over A. And there you go. There's a set of equations there for which you don't need to know the height. Nowhere in this equation here do you see a height. These only have the outside measurements and the angles. And that was our goal. And so what we've done is we've developed what's called sine law. Okay, so sine law works for any triangle. Okay, and it can be written in more than one way. So we could have written it like this: a over sine A is equal to b over sine B is equal to c over sine C. And so there you go. This one is good for finding sides because the sides are already on the top. You always want the thing that you're trying to find to be in the numerator or the top of a fraction. And so if you're trying to find angles, it makes more sense to leave it in the form we had before, since that way the angles are in the numerator. And there you go. And so both of these are just different forms of sine law, and they allow us to find missing sides and angles for non-right triangles. Now be careful, because you're only ever going to be using two of these. And you'll notice that in order to find this, you will always need to know three things. So for example, if you're after angle B, well then you'll need to know side B. And you'll need to know angle A and side A. Or you could have known angle C and side C. So you'll always need to know three things, and you'll always need a pair. See how we needed a pair? So an expression that would work maybe might be sine A over A is equal to sine B over B, where you know side A, angle A, and side B. Or if you were after side B, you would need to know side A, and angle B. So you always need to know three of the four terms in the expression or the equation that you're using. Okay, so I'll be back with another video that shows you some examples of how to use sine law.